Okay, yeah. Okay, so today we are going to continue the amplifier circuit, and let us see. So last time we studied the inverting and non-inverting configurations, and we saw that for the non-inverting configuration, the gain comes out to be equal to 1 plus R2 over R1. Hello. So the gain for between V out and Vin is positive, and it really depends on the it does not depend on A. هون اعتبرنا الأوبن لوب gain للأمبليفاير is really infinite in this configuration. And then we said, well, what if it were finite? Then it will really depend on the gain of the amplifier. هيدا هو open loop gain A. This is the open loop gain A. هون in the first configuration A tends to infinity, and in this configuration A is finite. So it is very important to differentiate between AV, which is the gain of the whole circuit. اوكي يعني كل هالشي بس بين ال VN وال V out, and the gain A, which is the open loop gain of the amplifier يلي هو هيدي ال A للامبليفاير يلي نحن بنكتبها VO equals ل A into V2 minus V1. So please, بس this is the most important thing to note here. Okay. So again, this has infinite input resistance, and the input and output signals are in phase. Type great. Now, what if I have this circuit and I said R2, and I said that R2 goes to 1 and R1 tends to infinity, or R2 goes to 0 and R1 tends to infinity? What happens to the gain here? This becomes 0, this becomes infinity, the gain becomes what? 1. يعني أنا إذا عملت هيدا short, okay, and this I opened it, then the gain becomes 1. So this is the configuration that we see here in this circuit home, where I'm applying the Vn to the positive terminal, and I'm putting a short to the negative terminal, and here I don't have the resistor that used to exist anymore. Okay, so this circuit, we call it the voltage follower, because really VO over Vn is equal to 1. Okay, so it's a voltage follower, and it has infinite input resistance لأنه هون ال I equal to 0, and it has 0 output resistance because of the short and because of the fact that here we don't have any output resistance inside the circuit, and also the input and output signals are now equal. So this is great when the signal has large R sig and the output has a small R load, because now instead of interfacing them directly, really R sig does not matter because I see infinite input resistance here, and the VO, this will be equal to Vn and the VO will be equal to Vn. Okay, هيدا الهدف from this type of voltage follower circuits. Okay, طيب, anybody has any questions? هلا the main reason why we have the difference amplifier is not to apply it in one configuration or other only, but also to create or find the difference between two signals. يعني I don't only want to put it to the inverting or non-inverting configuration, I really want to have two input signals, and those two input signals, let us say one of them can be written as some common mode signal minus a delta, and another one is a common mode signal plus a delta. And the reason why we do that is that we want to really, sometimes if I send just a signal, okay, and I add noise to it and I receive it and amplify it, I will be amplifying the noise to it. But now what happens if I send really my signal as a V common mode minus Vd over 2, and I send it as a V common mode plus Vd over 2. Okay, so let us say that these were opposite, sorry معلش رسمت in the opposite way. And now when I receive, let us say that the amplifier is going to give me an output which will be some gain times the common mode and some differential gain times the differential mode. Okay, and let us say that the common mode gain is 0 and the differential mode gain is 100. Okay, so what is the common part of the signal including the noise that gets added؟ شو بيطلع الفرق بين هيدول two signals? What is the difference between those two signals that had the same noise on the channel added to them? So if exactly, so if I say هيدي هي VB وهيدي هي VA، ساعتها VB minus VA هو حيطير الكومن منهم، حيبقى عندي هو VID. اوكي so accordingly عفوا حتى يعني الديفرنس هو VID so النويز طار من الجهتين. اوكي and also if my amplifier now does not amplify the common mode اللي هو VCM plus noise but it amplifies the difference اللي هو VID, then I will really get rid of the noise by virtue that my amplifier بيطير لي anything that is common even if it has noise and only amplifies the difference between the two signals. Okay, this is why I want the difference amplifier. This is the practical use of the difference amplifier. هلا now we're gonna look at the signal. And any signal I can send it to have a common mode and to take half of this VD signal and the other one to have a common mode and to take the other half but out of phase for the VID signal. So those two input signals, therefore now how do I find what is the VICM? It is the average. It is VI1 plus VI2 over 2, right? If I add them, this will drop and I divide it over 2, it will give me VICM. Okay, and what is VID as function of VI1 and VI2? VID is really what? It is VI2 minus VI1. And if I take VI2 minus VI1, I will be taking minus. This will become a plus, and this will be equal to VID. Okay, so this is equal to VI2 minus VI. Okay, so so I send two signals that have a common mode and that carry half of some small signal that I'm interested in called VID. Great. So these two signals now, in general, if I know that the amplifier, if my amplifier can take if my amplifier has two pins, and if it takes VI1 alone, the V output is equal to A1 times VI1, and if it takes VI2 alone, the output is going to be A2 times VI2, and we are assuming that we can have superposition. And if I get rid of one of the inputs, I get this gain with respect to VI2, and so on and so forth. So if I can characterize my amplifier to respond to V input 1 with some gain and to V input 2 with another gain, I can really convert this information into how much the common mode gain will be and the differential mode gain will be. What does this mean? Let's see. So VI1 is nothing but VICM minus VID over 2, okay? And VI2 is VICM plus VID over 2, okay? And I still have my amplifier here, A1 times this plus A2 times this. So I can group them and I can say, well, therefore, I will end up having VICM into something plus VID into something. And let us see what the pure math is going to tell me. VICM is multiplied by A1 and A2, so this will be A1 plus A2. And VID في عندها half, because it's here half, and it's multiplied into A2 minus A1. Okay, so now I can rewrite my amplifier in the form of VICM plus VID multiplied by the total common mode gain of the amplifier and the differential mode gain of the amplifier. قديش بكبر لي difference, how much it amplifies the common mode, where we can clearly see that the common mode can be derived from the initial individual input gains, and the differential mode the same, it can be derived from the initial individual input response or gain of the output with respect to this input. يعني ال ACM هي A1 plus A2 وال AD is A2 minus A1 over 2. So pure math. We started with the fact that I can find the gain with respect to V1 and with respect to V2, and I plugged their values in terms of common mode and differential mode, and I said, well, accordingly, this is your common mode gain and this is your differential mode gain. طيب هلا our objective is really to have a differential mode gain to be large and the common mode gain to be equal to 0. I don't want to amplify anything that is in common. I just want to amplify the signal that is carried differentially on those two inputs because I want to get rid of the noise as well. But the differential gain, if I want to find it, it is really VO over VID when VICM tends to 0. Okay, and the common mode gain is really nothing but VO over VICM when VD tends to 0, and it's clear from this equation that we have here. Our objective is we want to set this to 0 and to have this in our design, يعني design it such that, as we will see in the coming example, we can force it to be 0 and maintain AD to be large. So we want to get rid of this, and practically speaking, there is something called common mode rejection ratio, and this common mode rejection ratio is 20 log AD over ACM for my amplifier. And if my goal is for ACM to be ideally 0, so when ACM tends to 0, this whole quantity is going to tend to infinity. So a good amplifier will have a common mode rejection ratio that tends to infinity and will have a common mode gain which is equal to 0. Okay, حدا عنده سؤال؟ طب let us
Yes, Professor.
yes, go ahead.
Well, بس أول شيء how are we superposing A1 V1 A1 V1 and A2 V2 مش
هلا we
مش
see
تكون
an
A1
example.
V1 minus A2 V2.
No.
Oh, okay.
We'll take an example now where, okay, let me just repeat it here very briefly. Now we have two input signals, and those two input signals are VI1 and VI2, and they are inputted to arriving to the amplifier with some circuitry around my circuit, okay, around my amplifier, and this is VO. Hey, the VI1 is arriving somewhere and VI2 is arriving somewhere else, okay? Now, VI1 is really has some carrier part plus noise plus a common mode to send it plus VID over 2, and VI2 here real common mode plus minus VID over 2 or vice versa, right? هيدي حطوها minus. هيدي this is minus and this is a plus. Okay, so the amplifier will see this whole thing at this input and this whole thing at this input. And it will react. كيف نحن شفنا inverting amplifier مثلا إذا أنا حتى non-inverting, if I put VI here for it with this configuration, okay, it gives me VO is equal to some A times VI, AV times VI. In a similar fashion, أنا بعرف إنه any signal that arrives here, I don't know what it is carrying, and any other signal that is arriving here, I will have VO is equal to A1 times VI1 إذا درستها لحالها plus A2 times VI2. هلا now based on your question نادر, this A1 may be connected لأنها connected على النيجاتيف تطلع inverting gain صح؟ وهيدي ال A2 ممكن تطلع non-inverting gain بس أنا I'm not declaring anything. I'm saying if you are able to find what A1 is and if you are able to find what A2 is by virtue of superposition because my circuit is linear, the output is going to be the sum of the gain times each input. Okay, هلا one of them may be inverting, the other non-inverting. And things will happen, and I'm not sending it directly to the open loop amplifier تكون V2 minus V1. I'm sending it to the amplifier with some circuitry around it. Okay, so the gain هو ال AV2 بالنسبة ل input 2 and the AV1 بالنسبة ل input 1, and then by superposition I add. Is this clear?
Yes, it's clear. Thank you, Professor.
Okay, thank you. So now I have an exam. Now that if I can represent it in this form, I can definitely represent it, map it to this form, and high is represented as this, and the same for this one. And I can then set the parameters or the resistors of the circuit such that I get rid of the ACM and maintain only amplifying the difference of the signal. Okay, so let us take an example. So let me look at this circuit here. I have the basic amplifier block which has inside it the open loop gain A, and I have applied feedback resistor R2, R1 here, and I applied a voltage divider circuit ننتبه هون إنه current 0, R3 and R4. At this pin I connected input 1, and at this pin I connected input 2. Now my objective is to find the gain as A1 times VI1 plus A2 times VI2. Okay, and we are going to do it by superposition. By superposition, this means I deactivate one of the inputs at a time and keep one alive. Okay, so let us see how we can do that. So now, if I start with the first example, I used to have only VI2, so I'm going to deactivate it and I will keep the input here. Okay, by deactivating VI2, I'm finding the gain VO equal A1 times VI1. Okay, this is grounded, yani what is this voltage here? 0. We're going to assume that this is ideal, so A tends to infinity. Therefore, this node is 0, and this is really what? This is the inverting configuration that we studied before. لأنه فعليا ما بيفرق معي إذا هيدا 0 مارق فيه 0 current. خلص ما هو هيدا الكرنت هون I equal to 0 صح؟ So this node is really shorted to ground. ما بيأثروا مع resistors, right? لأنه هون ما عندي current I equal to 0. So V across R is 0 and this node is grounded. طيب هيدا بيقول لي إنه أنا I know إنه VO هو minus R2 over R1 times VN1. So this is the gain A1. Okay? So this is the gain A1. يعني أنا if I go back to the next slide, he is telling me هيدي ال I0 خلص هيدي النود صارت 0, هيدا صار inverting amplifier and VO equal minus R2 over R1. طيب. Now I want to, by superposition, I will turn off this input, هيدا حيصير grounded, and here I have the current is 0, okay, so I can really redraw the circuit. So let me redraw the circuit for you. So I really have an amplifier with the input terminal minus and the plus. I have VO, I have a feedback resistor here and a resistor here. هيدي بتشبه الconfiguration of the كنت أنا قبل حط عندي هون if I have V2 here applied or VI prime let us call it. then based on the non-inverting configuration كنقول إنه VO is equal to 1 plus R2 على R1 VO over VI prime, right? هيدي non-inverting configuration اللي درسناها من شوي. طيب I have a circuit that has VI2 here, that has R3, R4, عنده current هون رايح I equal to 0, and really I can declare this as VI prime. What is the relation between VI prime and VI2?
The voltage divider is R4.
Exactly.
R4 plus
So
R3.
VI prime هي R4 على R4 plus R3. Okay, so now I can use those two terms to find the overall gain for my amplifier. So therefore, what do we have? VO over VI2 is equal, هيدي هي VI prime هون, is equal to VO over VI prime times VI prime over VI2, which is equal 1 plus R2 over R1 times R4 over R3 plus R4, and this whole quantity here, what is it? هيدي كلها
VO over VI2.
exactly, هيدي is all of this is what is the A2 that I am looking for. Okay, so this is the gain A2, right? يعني أنا هلا I can write my output as A1 times VI1 plus A2 times VI2. حدا عنده سؤال? Anybody has any question? طيب great. Okay, so let us go down here. So this is the first A1, this is the A2. هو سمي لي إياها هيدي V plus النود اللي هون. أوكي، طلع الفولتج division، طلع لي overall gain. هلا all I want to do now is to really say if I have VO equal A1 times VI1 plus A2 times VI2, I'm going to plug VI1 and VI2 as function of the differential mode and common mode gains. ونحن كنا لقينا قبل إنه ACM هي A1 plus A2. We found also that AD was equal to, حسب what we just derived, it's equal to A2 minus A1 over 2. Okay, so let us see the derivation here. And now in this analysis, he started with A1 plus A2 times VI1 and times VI2. And then he replaced those quantities by their common mode and differential mode gains. And he ended up with this quantity here and this quantity here. This is A2 فعليا plus A1 اللي هي minus R2 على R1. And this is half into A2 minus A1. Okay, هيها minus A1 صارت plus R2, هيدا هي ال A2. Okay, so I found now the differential gain and the common gain. هلا my objective إنه set the resistors Ri such that A common mode يلي هي A2 plus A1 equal to 0. This is my objective, to get rid of the common mode and then I calculate what the differential mode is. Okay, طيب great, so that's our objective now. حدا عنده سؤال لحد هون؟ طيب let us see now what he does. This is AD, this is ACN. Now I have it in this form and I want to have only VID amplified, so I need to set ACM to be equal to 0. هلا هو هون بس عمل reduction mathematically. This is the expression. If I want to set it equal to 0, I will end up with R1 R4 equal to R2 R3. يعني numerator 0 يعني I will have a ratio R1 over R2 or R2 over R1 is equal to R4 over R3. So if I have the feedback R2 over R1, I must place resistors R4 and R3 here, and they have to have this ratio, and this is exactly why we put them here, so that we can satisfy such a condition and set ACM to be equal to 0. يعني إذا هيدا 10 1, this can be, I don't know, 22 or something like that. Okay? طيب, with this fact taken into consideration, if I take this ratio and plug it back into the differential mode gain, so for it to be 0, I need to maintain this ratio, and if I plug back this ratio in AD, I will end up with this being the output having this differential gain اللي هو R2 على R1, okay, which is R2 over R1. Okay, clear what we did? We found what ACM should be. We set it to 0. We found the corresponding resistor ratios that I need to design my circuit with. And if I reduce AD and plug those ratios, يعني I represent each R2 على R1 by R4 على R3 or vice versa. Okay, يعني هاي هي فعليا R2 على R1 plus 1 plus R2 over R1. Okay, into هيدي هي R4 على R3. يعني if I divide by R3, I will get R4 over R3 بالtop, 1 plus R4 over R3 بالbottom. I can replace them by R2 على R1, right? And see how this whole thing will reduce. هلا يمكن أنا مغلطة بشي constant أو شي, so I'm not going to derive it all now. But you got the gist of it, right? Okay. Okay, great. طيب. هون في half لأنه هي بتطلع 2R2 على R1 مضروبة بhalf, forget it. Okay. طيب, great. This is how we use it as a difference amplifier, and we can design now and rely on superposition to find our NS. هلا, one more thing that we add to the formula, إنه أنا I have my op-amp, it has an open loop gain A, هذا open loop. In reality, any circuit that I design, this has to be A of S. Okay, so whatever I design as A of S will have a finite bandwidth. Okay, so they start to say, well, if it has finite gain, in this example, for example, equal to 100 dBs, okay, then I can represent the A of S as AM, which is the low frequency gain, over 1 plus S over omega 3 dB. Right, this is the representation of my circuit. Now, of the gain of my circuit. But he introduces to the definition some Ft or omega t, which is the unity gain frequency, i.e. the frequency at which the magnitude of A of S becomes equal to 1. Type, if I have A equals to AM over 1 plus S over omega 3 dB, then the magnitude of A at any time is equal to AM over the square root. So the magnitude of A at any time is equal to the absolute value of AM over the square root of 1 plus omega over omega 3 dB all squared. Okay, and if I want to find omega t, I want to set this to be equal to 1. Okay, so I'm going to get rid of the square root and take this term up. So I will end up with 1 plus omega t over omega 3 dB all squared is equal to an squared. Okay, minus 1. نشيل هاي ناخد square root. Okay, so this means that omega t can be really written as omega 3 dB times this quantity. Okay, so this will be equal to omega 3 dB times this quantity. If AM is very large, okay, then this can be approximated as omega 3 dB times AM. Okay, so for any amplifier where I know AM and I know omega 3 dB, from now on I can approximate its unity gain frequency أو it crosses the 0 dB. Okay, صح, unity gain هو 0 dB at a frequency omega t which is equal to AM times the 3 dB frequency. What does this tell me? This tells me that anytime, okay, I have a finite bandwidth, I'm going to hit zero gain after some time. هات لنشوف هون. He's showing me that A is 100 dB. يعني A, the gain AM and A بيساوي إذا 20 log AM is equal to 100. يعني AM is equal 10 to the 5, right? And what is omega B هون أخذها frequency. Okay, so omega 3 dB is equal here 2 pi times 10, right? Therefore, I can directly tell you what is the unity gain frequency لأنها حتكون AM اللي هي 10 to the 5 ضرب 2 pi ضرب 10 يعني حتكون 2 pi ضرب 10 to the 6. Okay, so you can see here in small font it's showing me that I'm going to cross 0 dB at 10 to the 6 hertz. Okay, anybody has any question? طب هلا next we're going to see how this will play a role in the different amplifiers. يعني assuming that now my op-amp has A of S response and not simply a constant, يعني it varies with frequency, we're going to see how the different configurations will be affected. Now, if you recall, نحن كنا قلنا مثلا بالinverting configuration that the gain for the amplifier for finite A, for example for the inverting configuration, طلع معنا إنه VO على VN is equal to minus R2 over R1 over 1 plus R2 over R1 على A. Now all of a sudden this A has become what? This A is now an A of S. Okay? And therefore, since I have a 3 dB frequency for the open loop, I will also have a 3 dB frequency for the inverting configuration. Okay, so بيطلع من هيدي 3 dB frequency للinverting وللother configurations, and it is a pure math. So let us see how that affects the circuits under study. So, okay. So let's see for the inverting amplifier لكن نحن قلنا أن the configuration can be written as minus R2 over R1. I'm going to write this as 1 plus A over A of S. هلا ال A of S هون, the A of S, so this is my A. Okay, my A is the 1 plus R2 over R1 بس حتى ما ضلني اكتبها. وال A of S is what we just saw before, which is equal to AM over 1 plus S over omega 3 dB. يعني أنا here I have AM and this over the denominator I can bring it here up, right? So I'm just dividing by it. So here I'm going to multiply into 1 plus S over omega 3 dB. هلا what I'm going to do is I'm going to group all the constants in the denominator and keep the S term alone. يعني أنا as a constant I will have 1 plus A, and this will be over AM times 1. Okay, هيدا as a constant term. And then I will have plus A, okay, times S over omega 3 dB. Okay, plus A times S over omega 3 dB. But we distributed this, we split this. هلا I can take the A down, so I can remove this, and I can put it to determine what is my 3 dB frequency. Sorry, هون في عنا A over AM, عفوا, A over AM, pardon me. so let me بس write it back. So this is A over AM وهيدي هون حيكون عنا over AM وفوق في عنا A, right? So I can really now take A down, the little A down. So هيدي فينا نشيلها وحط هون ال A. So هي بتصير هيدي over, pardon me, بتصير هيدي this one. Sorry عم محي بدل ما أكتب, I apologize. هيدي S. Okay, this is S over. Okay, and this is still divided by A. بس math هلا. Okay, great. هلا we're going to look at two things. AM is very large, like 100,000. Okay, and A is smaller than it. So as a constant compared to 1, هون I can drop this term and get rid of it. Okay, هيدا بعتبرها negligible. طيب great. بصير هيدا هو minus R2 على R1 على 1 plus S over, and now my 3dB frequency. شو هي ال AM ضرب omega 3dB؟ من شوي we saw that this is what? That this is the unity gain frequency over A, where A is the 1 plus R2 over R1. So now if I want to define my system, therefore for the inverting configuration, شو هو ال low frequency gain؟ من هيدا ال equation, what is the low frequency
minus
gain?
R2 over R1.
Exactly, this is the low frequency gain. And also, what is the 3dB frequency?
Omega T over A.
Exactly, it's omega T على 1 plus R2 over R1. Okay, فإذا أنا I know AM and I know omega 3dB for the open loop. Okay, for this open loop guy. Okay, the whole system من V in V out حيكون عنده 3dB frequency اللي هي omega T على 1 plus R2 على R1, وحيكون عنده low frequency gain اللي هو minus R2 على R1. Okay, يعني this is what we want best to make sure that you got it and you're comfortable with. هيدا clear؟ حدا عنده سؤال؟ طيب اوكي. So بلشنا ب open loop system عنده pole, صار طلعنا البول للبيج للinverting amplifier system. اوكي طيب so لكن here they just continue to tell you that I'm going to end up with a 3dB frequency, and this 3dB frequency هي 1 plus omega T على 1 plus R2 على R1. هلا هون عم يعطينا example, and in this example he said well I have the op amp. Okay, so عندي ال op amp اللي عنده A of S, وهي ال A of S that we saw before. يعني عندها low frequency gain طلع معنا مرة الماضي 10 to the 5, 3dB frequency طلعت 10 to the 6, sorry unity gain frequency طلعت 10 to the 6, هون حاطتها F مش omega. Okay, and then he tells me well let me assume that R2 على R1 equal 10. So automatically I'm going to write that VO over VN for my amplifier هي minus R2 على R1, مش هيك بين معنا plus 1 على S ضرب omega T على A, يعني هي minus 10 صح over 1 plus S over what is this frequency? So omega T the 3dB frequency لأله حتكون هي omega T اللي هي 10 to the 6 over A اللي هي 1 plus R2 على R1 اللي هي 11, لأن هيدي 10 صح 10 to the 6 على 11 تقريبا 10 to the 5 hertz. Okay, so you can see here هيدا حاطط لي اياه كيلو هرتز, يعني هي بعد فيها 10 to the, يعني this is equivalent to 10 to the 5 hertz. So you can see here that he's showing me that the 3dB frequency for this circuit is near 10 to the 5 hertz. He's also showing me that the low frequency gain is 20 dB. ليش؟ لأنه أنا بعرف إنه هيدي هي أوميجا بي. ال low frequency gain هو minus R2 على R1, so 20 log absolute value of minus R2 على R1 هي حتطلع عندنا 20 log 10 اللي حتعطيني 20 dBs. Okay, فإذا from this A of S, if I know this and I know it's a 3 dB frequency, I can find the unity gain frequency, I can find omega t, and from R2 over R1 of course, and also I can find from R2 over R1 the low frequency gain. Okay, so we can now map A of S response to find the amplifier, the overall inverting op amp response. حدا عنده سؤال؟ طيب okay. Hopefully it is clear. Okay. طيب, so let us now, okay, if you notice here, what has he drawn? He drew for me the low frequency gain of the new circuit, and he showed me where the new 3 dB frequency is. So what happened here? I start with an op-amp with an infinite gain or very large gain, who 10 to the 5 volt per volt, right? I end up with an amplifier that has lower gain, but it has higher bandwidth. So هون بصير كأنها trade off. So basically it's as if, roughly speaking, we maintain the gain and the frequency يعني بالproduct. Okay, is a high hybrid. One goes smaller, one becomes larger, and vice versa. Okay, so lower gain was translated to a higher bandwidth. Okay, so I can rely on R2 and R1 to scale down depending on what response and gain I'm interested in. Okay, طيب great. هلا now we're going to look. Now we studied the frequency response, we studied the difference amplifier. We want to see, well, can this amplify forever? No, it will have some limitation. So this is what we call the large signal operation of the op-amp. So what are the limiting factors for the operation of my amplifier? First, my amplifier cannot output a fine infinite signal. يعني let us say that I find that the gain AV is going to be 16. Well, I'm not going to get, will result in VO and that's equal to 16. I cannot get it. I'm going to be limited by V plus, okay, and V minus, which are the output voltage maximum limits within which my signal can operate. ليش؟ لأنه أنا في عندي supplies I cannot skip. There are voltage drops in the circuit, so I really cannot satisfy the ideal gain. يعني أنا if I input, if let's say that the gain is 100 and my Vn, let us say, is 3 millivolt times sine omega t, right? And my VO is going, and let us say that V plus and V minus are really plus or minus 5. Okay, so in this case 3 millivolt times the gain of 100 قد بيطلعوا رح يعطوني VO 0.3 volts صح؟ So I'm safe, right? Now let us say that the gain is 10 to the 5. Would I really be able to deliver 3 millivolt ضرب 10 to the 5 مثلا 30 or even more? I don't know how many volts. Okay, so 300 volts. Can I deliver 300 volts? No, definitely not, right? I cannot deliver that much of a signal. Okay, so if my V plus and V minus are limited between plus or minus 5 volt, then any output within this range will pass, otherwise it will be distorted. يعني if output outside range, it will be distorted. Okay, as you see in this signal. So in this signal, it's showing me that the ideal output should be 15 volt, but really it got truncated at 14 volt. Okay, but the second limit on the amplifier is the output current. يعني the op-amp itself can deliver a maximum current due to heating and power. Okay, so let us assume that I have an, pardon me, a specific load, and let me say that I find based on my VO over Vn equal to some AV, that my VO is going to be 10 volt. Okay, but if I put a load resistor which is 1 ohm, then the current at the output, IO, is equal to VO over R, يعني هي هتطلع 10 amp. If this current, if my maximum current that I can support is 1 amp, then something will go wrong in the circuit. So I cannot support this. So therefore, maybe I have to put a 10 kilo ohm load here for me to satisfy that IO is equal 10 volts over 10K, which will give me now a 1 milliamp current, which is less than the maximum current that I can supply. Okay, so هون صار بس we need to make sure what is IO that is being delivered to the output and how does it compare to the maximum current limit. Now, of course, in real life, I can supply only few tens of milliamps. Okay? Okay, great. طب ليه عم بيقولوا source or sink؟ لأن ال output if it is fluctuating, the current will also be sinusoidal up and down. Okay? Great. So I can supply now. بس هلا في something that is very yes, anybody has any question?
I just have a quick question.
أيوة
The
كريم.
voltage saturation is decided by V plus will V minus,
Yes.
right? The current by the same thing. And
The
because the power
current,
produced.
these are two separate conditions. The current may be decided by the heating, the maximum power dissipation that we can tolerate in the circuit. So you will have three constraints. واحد هو ال V plus will V minus, a separate current constraint called I max. Okay, and let us say that if I tell you that I have Vn here A ضرب sine omega t, and that the gain is AV, and I end up with V out, which is 5 volt. Okay, it may pass this criteria, but may fail this criteria حسب ال R load which it is feeding, right? And the voltage is voltage, بس ال R load هو هيحدد لي ال I out. It may fail both, or it may pass both, or fail one of them, صح؟ So these are independent. هاي بتجي من ال VO range تاعون ال current mirror وال amplifying circuit, and this typically is from the maximum power that can be dissipated and the tolerance of the devices in the circuit. Okay,
All right, thanks.
thank you. طيب great. هلا في third condition which also need to be met, and they are somehow related بس إنه they are stated alone. هي slew rate. يعني it's the maximum possible rate of change at the output. مثلا if we look at the voltage follower, we say that VO equal Vn. But in real life, I cannot have the output step immediately. يعني there has to be some delay between the output and the input by the virtue that I have يعني circuits with finite power or finite capability. So the maximum slew or rate of change possible at the output اللي هي function of the elements and the delay circuits هي هنسميها ال slew rate. Okay, now what does this mean to us? So the slew rate is really dVo by dt max. Okay, so it is the maximum slope that my output can يعني typically the slew rate هي ال derivative of the output with respect to time, and the circuit has a predefined SR max. يعني let me assume that it can tell me that I can really maximally rise at a rate of 1 volt per microsecond. And let me say that I find that my output can really needs to rise this faster than this. What is going to happen? My output will have to abide by the slew rate. But if I have another output that will rise slowly, then it will not be distorted. Okay? Then there is, for each output VO, I can calculate dVO by dt max from the equation of the output. Okay, and I need to compare this to the pre-specified criteria, okay, which is the SR max that I am told of for the specific circuit. Okay, يعني هن بقول لي ال SR لإلك هالقد maximum. Calculate your DVO by DT. Find for me the maximum possible value of it, and let's see if you're gonna violate the criteria or not. Okay, so let's see what the examples will say. So, so here he's telling me now if I have Vn, this is step function for the voltage follower. This is the transfer function. هيدي بتجي من fact that if we rederive يعني just like we derived for finite A. طيب, let us not worry about how this was derived and let us look at the final output waveform. عم بقول لي if I put a step input, okay, and this is the transfer function, so the step input is 1 over S or V over S, then the resulting output voltage will be this much. Okay, can I calculate dVO by dt? If I have this term, it will be equal to V e to the ax بتصير a, يعني هون عندي minus omega times minus بتصير times omega t, right? Times what? Times e to the minus omega t. Okay? This is a constant I know. This is a constant I know. When is this maximum as function of time? بس بدنا نميز بين التايم t والأوميجا t تاعت الunity gain frequency. على أي time this becomes maximum? When t equals to what? What is the maximum value for this?
T is 0.
T is 0 and exponential بيكون 1. So this is equal of V times omega unity, right? So this means that the dVO by dt max depends really on the magnitude and depends on the unity gain frequency, right? Okay, and now this quantity I have to compare to the criteria S. Okay, so if I have here, this is how it's supposedly going to be, and I will start from 0, and as I tend to infinity, I will reach the value V, right? And هيدي at t equals 0, it is 0, كلها it evaluates to 0, and then at t tend to infinity, هيدا الترم بروح, I will end up reaching V. So this is how my curve will look like. It will have some slope. Its maximum slope is here, اللي هو نحن we just calculated, and I have to see if my slew rate, if my natural slew rate, اللي هي الكرايتيريا, if I am greater than it, then I will fail, else I will be fine. Okay, so for example, if the natural slew rate is هيدا example of a slew rate, do I have any problem here? إذا هيدي SR1 حدا عطاني criteria هيك? No, because my slope is lower, right? Now what if the natural slew rate is here? This will create distortion, right? So this is slew rate here. If this is my SR2, this means I will have a distorted output. ليش؟ لأنه أنا I cannot go faster than this. I have to abide by this and then get my signal out. Okay? فإذا we calculate dVO by dt max and we compare to the criteria that we have. Let us take a problem which is closer to our mind. Oh, sorry, I skipped the time. I apologize. Sorry. Okay, so I'm going to stop here. We will take a problem next time, and we will sinusoidal problem which is closer to us, and we will work on it. Okay. طيب, thank you very much, everybody, and we will catch up soon, inshallah. Anybody has any questions?
I just have one last quick question.
Okay. Yes.
Do we prefer إنه السلو rate يكون أعلى? Usually.
هلا, if the slew rate is high, definitely, then I can accommodate more types of outputs, right?
Yeah.
As we will see next time, we will get an example, see that we can adjust either the amplitude of the input or the frequency of operation to meet a specific slew rate. Okay?
Professor?
Yes, Luna.
بس عندي a small question عشان عملنا بأول الساعة.
Okay, please.
كنا عم نحكي عن differential والcommon gain. ما كتير فهمت كيف طلعنا A2. So you can re-explain, please.
So for this A2 here, what we did was we set Vn to 1. يعني إذا برجع على هيدا البيسك سيركت شو عملنا هون؟ We set Vn to 0, Vn1 to 0 عفوا. We got rid of it, صح? And we kept Vn2. And then we said, well, if you recall the non-inverting case, where I had some signal here, and I had a resistor like this and a resistor like this, we said that I know if I call this V plus, okay, I know that VO over V plus, what was it equal? It was equal to 1 plus R2 over R1. You remember this, right?
Yes, okay, خلاص فهمت كنت ناسي هالفورمولا. That's why.
Okay, no problem.
Okay, thank you.
طيب, thank you. طيب, anybody has any other question?
Thank you.
طيب, thank you everybody.